This is the video lesson for solving multiple step equations and inequalities. Here are our first two examples. And as you've learned in the last sections, solving one-step examples, to solve for your variable, you need to undo or do the opposite of what's happening to your variable. In example 1 here, though, you may notice that there are two things happening to your variable. First of all, your variable x is being multiplied by 2 right here, and then it is also being subtracted by 3. So when you are doing more than one step equations, you need to do the opposite of what's happening to your variable in the opposite or in the reverse order. So again, that is, do the opposite operation in the reverse order. So if you think of this problem as the first thing that's happening to x is it's being multiplied by 2, and the second thing that's happening to x is that it's being subtracted by 3, that tells you that the first thing you are going to do is this second thing, which is subtracting by 3. So the opposite operation of subtracting 3 is to add 3, and we again always do the same thing to both sides of the equation. So if I add 3 to my equation first, my negative 3 and positive 3 make 0 or cancel out. So my 2x is left on the left hand side, and on the right hand side, negative 9 plus 3 is negative 6. So we've done the opposite operation of the second thing that was happening to x. So now we need to also do the opposite operation of the first thing that was happening to x, which was the x was being multiplied by 2. So the opposite of multiplying by 2 is to divide by 2. We do that on both sides of the equation again. 2 divided by 2 is 1, so you have 1x equals, and then negative 6 divided by 2 is negative 3. And again, you don't have to write this 1 in front of the x. You could just say x is equal to negative 3. That's the same as saying 1x is equal to negative 3. Okay, so for example 2 here, we have 13 minus 11d is greater than or equal to 79. We will again look and see what is happening to the d. Well, first thing that's happening in the d right here is it's being multiplied by a negative 11. And then the second thing is there's a positive 13 here being added to the equation. So again, we're going to do the opposite operation in the reverse order. So if the last thing that was happening to your x is this positive 13 here, I am going to subtract 13 for my first step. And again, always on both sides of the equation or inequality symbol. Positive 13, negative 13 cancel. You're left with negative 11d greater than or equal to 66. And then last step here is d is being multiplied by negative 11, so I divide both sides by negative 11. The negative 11s cancel or turn into a 1, and then you're left with d. And remember, anytime you multiply or divide by a negative sign, you have to flip this inequality sign, so it's no longer a greater than or equal to, it is now a less than or equal to, and then 66 divided by negative 11 is negative 6. So d is less than or equal to negative 6. Okay, here are our next two examples, and remember, at any time you're watching this video, pause if you want to maybe try one of these on your own before I show you how it's done. Definitely do that. Use these as examples. Pause the video, try to work the problem out yourself, and then resume the video to see if you did what I've done in the problem. So, example number 3 here, we have w being divided by 8 and then being subtracted by 13. So again, the first thing that's happening to w is dividing by 8. The second thing is subtracting 13. We're going to do the opposite operation in the reverse order. So that means the first thing we will do is add 13 to both sides. again, leaving us with w divided by 8 greater than, and then negative 6 plus 13 is 7. And then the last step here is the opposite of dividing by 8, which is multiplying both sides by 8. Again, 8 is considered to be 8 over 1 in fraction form, so numerator of 8 and denominator of 8 cancel out or become 1s, and you're left with just w. Now remember, since I am multiplying both sides by a positive, my sign stays the same. I do not need to flip my inequality sign. It stays as a greater than sign. And then 7 times 8 is 56. So w is greater than 56 for example 3. Example 4, let's kind of pick up the pace here. First thing that's happening is dividing by negative 3. Second thing that's happening is add 5. So I am going to undo that by subtracting 5 first, leaving me with x divided by negative 3 equals positive 7 minus 5 is 2. And then the second step will be to multiply both sides by negative 3. So negative 3 over 1 cancels with x over negative 3, leaving you with just positive x, and then 2 times negative 3 is negative 6. Now, you've been hearing me say, do the opposite operation in the reverse order. If you've noticed here, the reverse order is always that you're going to do your adding and subtracting before you do your multiplication and division, simply because that's the order in which the operations are happening to your variable. All right, example number 5 here looks slightly different than what I just said on the previous slide, because x is not being divided by 5 in this case. X plus 3 is being divided by 5. So in this situation, the first thing that's happening to x is that it's being added by 3, and then the second thing that's happening is the whole equation, the x plus 3, is being divided by 5. So in this situation, you actually do the multiplication before you do the addition or subtraction, because in this case, in this specific case, the division was the second thing that was happening here. So for problem number 5, since the second thing that was happening was the whole equation was being divided by 5, we will multiply both sides by 5. Again, cross cancel your 5s. You're left with x plus 3 equals 10 times 5 is 50. And then for our final step, x is being added by 3, so you will subtract 3 on both sides, and that leaves us with x equals 47. Very good. Again, maybe you should pause the video and try this number 6 example on your own and see if you do the same thing I did here. Lots of things are happening to your variable here. X is being multiplied by 3. We'll call that the first thing. Then it's being added by 8. There's your second step. And then it's being the whole equation. Everything is over or being divided by 2. So this one actually has 3 steps. 3 things are happening to your variable. So we're going to undo these by doing the opposite operation, and we're going to work in the reverse order. So start with your third thing, then second, then first. So last thing that's happening here is the dividing everything by 2. So the first thing you need to do is to multiply everything by 2, or multiply both sides by 2. Again, 2 over 1 means the numerator 2, the denominator 2 cross cancel, leaving you with negative 3x plus 8 is less than 20. Then we will subtract 8 on both sides. So negative 3x is less than 12. And then the last step is to divide by negative 3. And x, don't forget you divided by a negative, so you need to flip your inequality sign. X is greater than Negative 4 would be your answer. Very good. Okay, here we go. Almost done. 2 more examples and then a couple of story problems. In example number 7, look for the things that are happening to your x, or to your variable. In this case, the variable is n. N is being multiplied by 2/3 and then subtracted by 6. So we will undo those in the reverse order. Excuse me. Last thing was subtracting by 6, so I am going to add 6 on both sides, leaving me with 2/3 n equals negative 4. And then remember how you get rid of a fraction. If you have a fraction multiplied by your number, by your variable, you actually multiply by the reciprocal, which is what happens when you divide by a fraction. So dividing by a fraction, dividing by 2/3 means to multiply by its reciprocal, which is 3/2. On the left sides, the 3's cross cancel and the 2's cross cancel, leaving you with just your n. On the right side, negative 4 is over 1. So again, you can do this 2 different ways. You could just multiply straight across. Negative 4 times 3 is negative 12 over 1 times 2, which is 2, and negative 12 divided by 2 is negative 6. Or you could have cross-canceled some in that problem. Okay, number 8, same kind of thing, except we have an inequality. And the problem kind of looks a little different, kind of in the reverse order. You find your variable. Here's my x. X is being multiplied by 1/5, and then it has a plus negative 12, so you're actually subtracting 12 from this equation. So we'll undo this by adding 12 to both sides first, leaving me with 1/5 x less than, is less than positive 9. And then again, I have a fraction here, so I'm going to multiply by the reciprocal. The reciprocal of 1/5 is 5/1. So the 5's cancel, the 1's cancel, left with x. Again, I multiply by a positive, so I do not need to change my sign. 9/1 times 5/1 is just like 9 times 5. So we have 45. So x is less than 45 for our answer. All right, in example number 9, we have a word problem here. It says, find 3 consecutive integers whose sum is 42. All right, the first thing that we need to do is understand what some of the vocabulary here means. First word we come across here is consecutive. Consecutive means in order, like right in order. And integers means whole numbers, both positive and negative whole numbers. So when we're looking at the word consecutive integers, we need to be thinking of things like 3, 4, 5. That would be 3 consecutive integers, or 80, 81, 82, or negative 12, negative 11, negative 10. All of these are examples of 3 consecutive integers. And then the last vocab word, which we should all already know here, is sum. Sum means to add, or means addition. So we are looking for 3 consecutive integers whose sum is 42. This is how I would set this problem up. I'm going to think, okay, I don't know what any of these numbers are, so I'm going to think of it as 3 blanks. And if you're in my class, you've seen me do this type of work before. So I am adding 3 numbers together, and their sum is going to equal 42. Well, I don't know what any of these numbers are. Well, if I don't know what the first number is, like again, you're talking about consecutive integers, let's just pretend it was 2, 3, 4. If I don't know what this first number is, I'm going to give it a variable. I'm going to call the first number x. Well, I don't know what the next number is either, but I don't want to call it y because that's not going to help me. I don't know what the second number is, but I do know something about the second number. I know that the second number is simply going to be 1 bigger than the first number. So write it like that. The second number will be x, meaning the first number, plus 1. And then again, the third number, I don't know what it is either, but I do know that since it's a consecutive integer, it'll be 2 bigger than whatever the first number was. So the first number was x, so the third number will be x plus 2. So this problem really breaks down pretty easily. You simply have an equation that says x plus 1 plus x plus 2 equals 42. Well, how do we go about solving this? Well, the first thing would be to add together like terms. Here you have x, meaning you have 1x plus another x plus another x, means you have 3 x's. And then you have your positive 1 plus 2, so you have 3 x's plus 3 equals 42. So hopefully here you can tell, or you can see, that we have a multiple step, or in this case a two-step equation, where you're going to undo what's happening to x in the reverse order. So let's go back and do that now. X is being multiplied by 3 and then added by 3. So we're going to undo that by subtracting 3 on both sides. Gives me 3x equals 39. And then my last step will be to divide both sides by 3, giving me x equals 13. 39 divided by 3 is 13. So there's what x equals. But again, this is a story problem, and the story problem asks to find 3 consecutive integers whose sum is 42. So you're going to say the 3 consecutive integers whose sum is 42 are, and your first number was 13, so that means your second number would be 14, and your third number would be 15. So the 3 integers are 13, 14, 15, and you could obviously pretty easily check this by taking 13 plus 14 plus 15 and seeing that that is indeed equal to 42. All right, example number 10, in our last example here, we have the same exact problem as we did before. The only difference here is that we do not have 3 consecutive integers, we have 3 consecutive even integers. So again, just thinking about what that means is, we would have 3 even integers in a row. So you might have 4, the next consecutive even would be 6, and then 8. Or you could have 12, 14, 16, or you could have, negatives, negative 20, negative 18, negative 16. Those would be 3 consecutive even numbers, integers. Okay? Now, we don't know, though. We don't know what we have yet. We just know what it means to have 3 consecutive evens. So again, I'm going to set up this problem the same as I did the last problem. I'm going to give myself kind of 3 blanks here, and the 3 blanks are added together because it says sum, and in this case the 3 blanks equal negative 42, which means that should right away in your head make you think, hey, wait, if I'm going to have a negative answer, I'm probably going to have negative numbers here. So same setup here. Again, do you know what the first number is? No, all I know is that they're consecutive evens like 2, 4, 6. I don't know what that first one is. I call it x. What I do know is now that the second one is not just 1 bigger than the first one. The second one is actually 2 bigger than the first number. So x still representing my first number. The second number would now be x plus 2. And then the third number, again, would be 4 bigger. So it's going to be x plus 4. So, I want you to understand, again, before I solve this problem, that this problem is going to be the exact same even if this said odd integers. Because, again, if you're dealing with odd integers, you'd have things like, 3, 5, 7. But, again, the 3 would be the first number that you don't know. The next number is still just 2 bigger. It's not 3 bigger or 1 bigger, it's 2 bigger. So you would still have x, x plus 2, and x plus 4, whether this problem said even or odd. Because even numbers are 2 apart, as well as odd numbers are 2 apart. So here's our setup. X plus 2 plus x plus 4 equals negative 42. I'm going to go ahead and right away combine like terms. X plus x again gives me 3x, and then 2 plus 4 gives me 6 equals negative 42. Go about solving this same as we have all the other problems. Subtract 6 on both sides. 3x equals negative 48. And then we are going to divide, change my pen, divide both sides by 3, and we get x equals 16, negative 16, sorry, negative 16. Now, be careful here, because again, we're dealing with consecutive even integers. If your first number is negative 16, that means that your first number is negative 16. That means that your next numbers will be negative 16 plus 2, which would be negative 14, not negative 18. And then your third number would be negative 16 plus 4, which would be negative 12. So your 3 consecutive even integers whose sum is negative 42 are negative 16, negative 14, and negative 12. And again, you can always check this by adding those 3 numbers together and realizing that, yes, they do indeed equal negative 42. All right, very good. Those are your examples. Good luck in this section. Solving multiple steps equations is a definite must for the world of algebra, something that's very important in now and in future problems. So you may begin on your assignment.